Alright, this is the last video that I'm going to make on this They Are Billions clone. Then we'll move on to another fun example. In this last one, I just wanted to cover the ways that the game is rendered on the screen. Remember that in the main method here, example5.py, we had just g.render. So we can follow that into the game render code, which is here. Okay, if self.terrain.rect.collidePoint mouse pause, that's saying that I've got two maps here on the screen. One of them I call terrain and the other is called territory. That's because they're sort of, any tile can both have information about whether it is soil or open space or inaccessible space, and that's terrain data, or it could have information about whether it's a user-owned tile or a user-owned perimeter tile or not owned by the user. So because those two pieces of information are separate, and because I guess I'm a little bit lazy, instead of making a separate object for each tile and giving it those items as attributes, instead I just made two big arrays, each of which is its own object. So terrain and territory are these objects. I'll show you how they're instantiated here in init. So here self.terrain equals screen map, and screen map is yet another one of these objects that I've got here in my closet. Screen map, it takes upper left coordinates and information about how big it should be, a file to load from, and a callback function, just like a button, you see? So when you click on the map, it tries to expand. More on that later. For the territory map, we give it an empty string instead of a map string. And that means that the territory starts out as zeros by default. Okay, let's look a little bit at the screen map code here. So here's where it's initialized. At the very beginning, it calls load map. Okay, now let's go down and look at load map. So I've defined a function called load map, and it checks to see if the file is there, loads it in, uses the json.loads method to load the string data into the map, and then it closes the file. So it's pretty simple. You can see here that if the file name supplied is an empty string, then it will seed the map with zeros according to the map size that you supply. And that's effectively what it does for the player territory. You could experiment with starting the game out with giving the player some territory. I just chose not to do that because that sort of requires that the map have some resources in that area. And for example, this map has no resources in the middle, so that would be a little bit mean. Okay, now let's look at the render function associated with the method and class game. Okay, so we'll go back down here. We can see that rendering, it checks to see if the mouse is over the screen, and if it is, it uses a method called setDiskIndices, which both identifies locations where yellow squares should be drawn and writes them to a list inside the terrain object. That way they can be rendered as yellow squares. If the mouse isn't on this terrain object at all, then it doesn't render anything. So that's why the yellow squares disappear when my mouse goes off the screen. Now, I thought about making every one of the tiles on this map a button, but I didn't think that was a particularly good idea, because the game has to iterate through each of the buttons to see if the mouse is on top of them. And this is actually a 50 by 50 map, and I thought it might take a lot of computing resources to check whether a point is inside a rectangle 2,500 times every frame. It might not be so much that you notice the slowdown, but it just didn't seem like an efficient way to do things. So that's why I made this whole separate terrain object to store this array, because after all, if you have an array, it's somewhat trivial to determine where in the array you've got your mouse. This getIndices function does that. It simply subtracts the point that you've got from the upper left coordinates, which happen to be 0 in this case, and then does a floor divide by the spacing of the array, and that directly returns the array indices. So just a little bit of arithmetic saves us the trouble of trying to check 2,500 different rectangles. If you can find little optimizations like these, you can do them. Probably it'll just make you feel good, and it won't have very much impact. At least that's been my experience. Optimizing the wrong thing because I haven't spent time actually determining whether it causes the code to run more slowly or not. Okay. But we're doing this for fun, so I don't think we have to feel bad about it. All right. What are we at? We showed how the disk indices are generated. Now we're just getting through the final rendering. So all we do is we set up the disk indices that show this yellow square. We fill the screen with black, and then for S in self.screenObjects. So I generated a list of these objects that are on the screen. See, we've got these buttons, self.b1, b2, b3, b4. We've got self.terrain and self.territory. And then we just add them all to a list, self.screenObjects equals, and then I make this list, and I just put each element in it separated by commas. So if I want to access the terrain directly, I just call self.terrain, and now I've got it, and I can call methods in it. But if I want to access everything that's on the screen, then I can just iterate through this list called screenObjects. It's a nice way of having multiple references to the same thing. That way, I can simply render all the objects by iterating through them all and calling all of their render methods, as you see here. I just make sure that each of the objects that are in this list have a render method. So there's a separate render method for buttons and for screen objects, like a screen map. And now lastly, I've just got this manual mess where I blit to the screen a bunch of rendered font items. In Pygame, when you render a font, it produces a new surface. We haven't talked much about how Pygame represents surfaces and the screen that you can draw to. Suffice to say that this series of commands, screen.blit, font.render, and then supplying it with all the text that you want, will, with the appropriate additional arguments and positions, render text to a certain place on the screen. And I simply format the game numbers, like the amount of money you have, as decimal numbers with a certain fixed width so that the spacing doesn't get messed up as the numbers change in width. And that renders everything as I want it. So there you go. A very quick look at kind of an exhaustive example where I've tried to recreate this game, They Are Billions, in Python. Hope you liked it. Let me know in the comments. See you next time.